Today we are going to demonstrate the RF PRO-1B magnetic loop antenna in a very noisy electrical environment to show you the advantage of this antenna versus a normal antenna. This class of antenna is what's called a shielded magnetic loop. It consists of a 1-meter aluminum tube structure, a low noise high gain preamp that amplifies the output of the loop, and this power inserter that multiplexes DC power for the preamp on the same lead-in cable that carries the signal to the radio. Radio waves, just like all electromagnetic radiation, consist of two components, a magnetic field and an electric field. In this animation, the red lines represent the electric field, while the blue lines represent the magnetic field. Our antenna is designed to optimize reception of the magnetic field and to block the electric field. This is exactly the opposite of a normal antenna that's optimized for reception of the electric field. Since most of the noise and static we hear on our radios that is caused by local interference sources such as fluorescent lights, power line noise, light dimmers, etc., have very high electric fields, this loop is much quieter and more immune to interference since it's designed to block these electric fields. The downside, however, is that since the magnetic fields of the desired signals are very weak compared to the electric fields, it's necessary to amplify them in this high-gain, low-noise preamp to get them up to a level that is usable by the radio. This adds to the antenna's cost, but the noise reduction is worth it for many users. To illustrate the principle, we have this off-the-shelf active MFJ whip antenna, which is representative of normal antennas that are designed to receive electric fields. Its control unit is connected to one input of this antenna switch, while the other input of the switch is connected to the magnetic loop. The output of the switch is connected to a software-defined radio, and we are looking at the received spectrum on this monitor. Both antennas are set up near a number of overhead lights on a dimmer that are generating a lot of interference. The radio is tuned to a local broadcast station, and we can see the received spectrum in this window. Right now we're connected to the loop, and I'll turn up the volume so you can hear the audio.
A lot of fans who are going to be upset when they've been used to, 9 and 3, 8 and 4.
When I switch to the normal antenna, this is what we get.
Because that level of comfort, I guess they weeded out all the so-called lesser schools, and now the level of comfort.
From the spectrum, you can see that the carrier is still there, and it's a strong signal. But what's happened is that the noise floor has come up to almost obscure the carrier. When I switch back, the carrier's still there.
They bought in, they wanted the money, and
and it's the same amplitude, but the noise floor has dropped way down, so the signal-to-noise ratio is vastly improved.
Front range that are going to have to make a decision, in the next couple of years, who they want.
Now we're listening to the magnetic field.
Yeah, and it's a great.
But when I
point,
switch
John,
back,
in terms of CU,
here's what you get.
In the Pac-12, it's a natural fit. 80% of the CU's alums live on the West Coast. Most of the kids they recruit are from there. But your point is
back to the magnetic field, and the noise is gone.
So many schools that are basically in a situation where it's almost like...
And because this is an untuned broadband loop, we can see in this lower window, which covers all the way down to 50 kilohertz and up to 30 megahertz on the high end, that we get a noise floor improvement at almost every frequency across the band of 20 to 30 dB. That's the electric field. That's the magnetic field. I'll do it again. Electric field, magnetic field. You can see the noise floor drop. Another advantage of the loop, which is very useful, is its figure-8 pattern to low angle of arrival local signals. These very sharp nulls at right angles to the plane of the loop can be used to gain additional rejection of local unwanted signals or noise sources. For example, you can see as I rotate the antenna about its vertical axis, I can find a spot where the received amplitude of this local radio station is reduced by 25 dB. But the high angle of arrival signals, like what we get at night bouncing off the ionosphere, it has an antenna pattern which is almost omnidirectional. But you can still use it at the same time to reject these local unwanted signals. Many users compare the performance of this loop to much larger antennas. Please click on the links on our website or in the description below to see some of the outstanding reviews for this antenna.